Hi, my name is Mira and welcome to another session of Drax virtual tours called Pulverising Nodes and Efficiency. In this session we're going to look at the first stage in the generation process and explore what efficiency is and why it is important. I'm also going to ask you some questions along the way, so if you want, grab a pen and some paper. Let's begin. Before we get to the power station and explore what efficiency is and how we can increase it, let's take a step back and look at energy and the law of conservation. So what is energy? Energy is a key principle in physics, as it allows work to be done. So, for any work to be done, we need energy, and this includes everything from making our turbine spin to walking, breathing, working, cooking, and even resting. In fact, energy is everywhere around us. But can we make energy? To answer this question, I will take you back in time and tell you about a little-known French philosopher and mathematician who in the 1730s translated and commented on the works of Isaac Newton and suggested for the first time the conservation law for total energy, better known nowadays as the law of conservation of energy. Now, let's get you to meet this incredible person. Her name is Emily du Châtelet. Surprised? Did you expect it to be a man? I hope not. Okay, so the law of conservation of energy states that energy can be stored, transferred between stores, or dissipated, but it can never be created or destroyed. There are 8 different energy stores, and according to the law of conservation of energy, it can be transferred from one store to another. Now let's have a look at them. So we've got kinetic, thermal, chemical, gravitational potential, elastic potential, electrostatic, magnetic, and nuclear. The transfer can be done in 4 different ways: mechanically, electrically, by heating, and by radiation. However, most energy transfers involve some losses. So here is an important principle. Energy is only useful when it is transferred from one store to a useful store. But some of the input energy is always lost or wasted. So applying the law of conservation of energy means that the total energy input equals the useful energy input plus the wasted energy. The less energy that's wasted, the more efficient the process is said to be. So efficiency of any process or device is defined as the proportion of energy supplied that is transferred in useful ways, and it's measured in joules. In simple terms, we want to get the maximum results, putting minimum effort and power. Before we continue with the power station, let's have a quick recap on what we've learned so far. It's question time. Question 1. What is the law of conservation of energy? A. Energy can be stored, transferred between stores, and dissipated, but it can never be created or destroyed. B. Energy can be created and destroyed. Or C. Energy cannot be transferred between stores. Correct. It's A. Energy can be stored, transferred between stores, and dissipated, but it can never be created or destroyed. Question 2. What is efficiency? A. How quickly you can do your homework. B. The proportion of energy supplied that is transferred in useful ways. And C. the amount of money you spent on food. Correct, it's B, the proportion of energy supplied that is transferred in useful ways. Now that you're experts on energy and efficiency, let's go back to Drax power station. First, a quick recap of what happens before the fuel is brought into the station. We source the biomass from sustainable working forests, which actively maintain and replant the trees to ensure the health of the forest and continuous supply. Then, we bring the fuel to the UK using big ships and load the biomass into specifically designed trains to move the fuel from the ports to the station. When the trains arrive at the power station, the fuel is transferred through conveyor belts and put into stores called ecodomes. From there, the biomass is transferred to the pulverising mills via another set of conveyor belts. This is the first stage of the generation process. However, what do we mean by generation process? The generation process is a process in which a set of machines converts the energy of the fuel into electricity. This set of machines is called a generating unit and consists of 10 mills, a boiler, a turbine set, and a generator. Each generating unit at Drax can power 1 million homes with electricity, or in other words, a city the size of Leeds. The generating process begins with pulverizing the fuel. As I mentioned earlier, the biomass arrives on conveyor belts and it's put through our pulverizing mills. The fuel is ground into very fine powder fuel, which becomes as fine as baking flour. The pulverizing stage is a very important contributor to the efficiency of the overall process. The pulverizing mills are very big machines weighing around 400 tons each. Altogether, there are 60 pulverizing mills in Drax power station, 10 mills per generating unit. In the mills, we grind the fuel to a very fine powder to increase the surface area of the product, thus increasing its efficiency when injected and used in the boiler. How do we do this? Let's have a closer look at the structure of a pulverizing mill. The fuel enters the mill from the top and is dispersed by centrifugal force on the 10 1.3 ton steel grinding balls. Each one is as heavy as a small car. The mill balls sit inside two cupped rings, a structure resembling a huge ball bearing. The cupped rings are positioned between two plates, with the bottom plate rotating, driven by a motor, and the top plate exerting pressure on the system with 8 hydraulic rams. As the mill balls rotate, they crush the fuel into powder. The hot air picks up the pulverized fuel and pushes it out of the mill through two pipes at the top. The pulverized fuel is carried by the hot air and injected into the boiler. But why does the air need to be hot? Well, it all goes back to efficiency. If we put cold air into the mills, the cold air will end up in our boiler. The cold air will cool it down and decrease the boiler's efficiency. The same is relevant for the air or oxygen we put in the boiler for combustion. But how can we get hot air without spending extra fuel for heating it up? To supply our mills with hot air, we have an airflow system which uses two different types of fans, FD or forced draft fan and PA or primary air fans. The FD fans or forced draft fans collect warm air from the top of the boiler house as residual hot air rises to the top. The air is then pushed through a heat exchange system which allows heat from the pipes carrying exhaust gases to be transferred to the air collected from the top of the boiler house, thus increasing its temperature considerably. Around 60% of this hot air is directed to the boiler and supplies the oxygen for the combustion process. The rest goes to the primary air fans, which are connected to the mills, moving the pulverized fuel from the mills to the boiler. Efficiency at this stage is achieved by harvesting our own residual heat, which is dissipated or released by other processes, and putting it back into the system. Now, can you guess the overall efficiency of Drax Power Station by the following diagram? Let's have a quick look at some numbers. Around 5% of the energy is lost through emissions, 2% within the ash. The biggest 50% loss is heat to cooling, mechanical and generator losses. Around 2.5% is works power, and the useful energy going to customers is only about 40% of the initial energy in the fuel. If you thought it's about 40%, then you're right. The more efficient the whole process of generating electricity is, the less fuel and other natural resources we use and waste. Now let's have a quick question time and remind ourselves of some facts about Drax Power Station. Question 1. Why do we pulverize the biomass to very fine powder fuel before we inject it in the boiler? A. To transport it easily. B. To increase its surface area and efficiency. And C. To increase safety. You're right, it's B. To increase its surface area and efficiency. What is the overall efficiency of Drax Power Station? A. 60%, B. 5%, or C. 40%? Correct, it's C. 40%. With energy consumption rising, it is important that industries, transportation and customers in their homes use energy more efficiently so that less is wasted. Let's have a look at some of the benefits of increased efficiency at home. Lower emissions of greenhouse gases and other pollutants. We can decrease the water usage. We can reduce plastic waste, save natural resources, improve air quality, and lower individual energy bills. We all have a role to play. Small actions and changes that we do every day have a lot bigger and direct impact on the world than we think. So what can we do? Well, we can change small things like walking, cycling, or using public transport rather than fossil fuel powered cars. Using smaller, more energy efficient cars. Reducing the number of aircraft journeys taken, especially short haul flights. What else can we do? Well, we can remember to switch off lights, power sockets, phone chargers and televisions when not in use. We can use energy efficient light bulbs and rechargeable batteries. We can recycle and reuse plastics and oil-based products. What can we do in our houses? We can insulate house roofs, block drafts, use double glazing and more efficient heating systems. Consider the introduction of solar panels or switching to an electricity supplier that supplies green electricity. And finally, I have just one last question for you. What will you do today to become more energy efficient? Thank you for listening, and I hope to see you soon at Drax Power Station. Bye bye!